Let's take a look at this problem. We want to find dy dx, so find derivative. So we've got xy plus x is equal to 7. Okay, now I'm going to use implicit differentiation. And implicit differentiation says you take the derivative of everything where it's sitting. So I'm going to take the derivative with respect to x of xy plus the derivative with respect to x of x and the derivative with respect to x of 7. When I say take derivative of everything where it's sitting, see what's separated by pluses, minuses, and equals? So I take derivative of the xy times the x of the x and of the y. Well, the xy, this is the product rule. We've got something times something else. So this will be our p and this will be our q. We need p prime. The derivative of x is 1. We need q prime. The derivative of y is 1. We're taking the derivative with respect to x though, and it's really y, so we have to add on our y prime. Now our formula for the product rule is p prime q plus p q prime. P prime we said was 1, so plug that in, times q, which was y, plus p, which is x, times q prime, which is y prime, plus the derivative of x is 1, and derivative of 7 is 0. So we got y plus x, y prime, plus 1 is equal to 0. Now we want to solve for y prime. So I'm going to get everything with y prime on one side, everything else on the other side. So I'm going to take this 1 over, and I'll take this y over. And that gives us xy prime is equal to negative y minus 1. Now we're going to divide both sides by x. So we've got xy prime divided by x is equal to negative y minus 1 divided by x. These x is going to cancel. And we get y prime dy dx, remember that's just different notation, is equal to negative y minus 1 over x. Okay. Just for fun, let's go back to our original problem. This is one that we could actually solve for y. So I got xy plus x is equal to 7. Let's find the derivative solving for y. So I'm going to take this x, move it to the right side, and we get xy is equal to 7 minus x. Then we're going to divide everything by x. So divide by that by x, divide the 7 by x, and the x by x. Those x's cancel and gives us y. This is, if I were to take that x up on top, it becomes 7x to the negative 1. Remember, it's x to the positive 1 down here, and I take it up on top in a sign of the exponent changes. Minus 1. Okay, take derivative of it now. Take your power, put it out in front, lower it by 1. Negative 1 minus 1 gives us negative 2. 7 times negative 1 is negative 7, and I'll take the x and negative 2 back down below. And we get negative 7 over x squared. Well, let's compare that against this. They don't look the same, do they? Sometimes that happens in implicit differentiation. So you work it this way, and you get this, and somebody else works it this way, they get a different answer. Let's look at our original problem. xy plus x equals 7. xy plus x is equal to 7. Now I already solved for y up there, so I'll quickly go through this. Plug that in, move that x over, so that's 7 minus x. Divide everything by x, and we get 7 over x minus 1. Okay. If I wanted to simplify that so it had all x's in there, what I could do at this point, and I'm happy with this answer right here, by the way. That's what I'll put in the key. But you could go further. Replace the y here with 7 over x minus 1. So we'll have negative 7 over x minus 1 minus 1 all over x. Well, negative in front of the parentheses flips the sign of everything, so that becomes negative 7 over x. Negative negative gives us a positive 1, minus 1 over x. 1 minus 1 drops away, and we got negative 7 over x all over x. This is a complex fraction, fraction inside of a fraction. We're going to multiply everything by the LCM of all our inner denominators. Here's an inside fraction, and it's got its own inner denominator. So we're going to multiply top and bottom by x. So multiply the negative 7 over x by x, and multiply the x by x. And those x's cancel, and we've got negative 7 over x times x is x squared. So we end up with negative 7 over x squared. So you see it gives the same value there. So again, sometimes you may come up with items like this, and you're sitting there, boy, this is just, I've done something really wrong. Not necessarily. If you were to take it further and solve for y and then plug that in, you might find that it gives you the same result. Anyway, that's the first problem.